Welcome everybody, this is Mark Anderson from Kellogg Community College, and what I'm going to do today is give you a quick introductory lesson in sequences. Now, a sequence is an ordered list of numbers. So what we're about to do is we're about to create our first set of list of numbers from this equation right here. And a couple things to note about the notation. A sub n, this denotes the answer for what I get when I plug in a number for n. And sequences start with 1. A lot of us kind of think when we look at a number line, we count from 0, but typically sequences start with the first term. So we usually start with a sub 1. And a sub 1 is where we plug 1 into the n value here, so this would be 1 minus 3, so my a sub 1 would be negative 2. So as we look at the instructions here, which is write the first 4 terms of the sequence whose nth term is given by the formula, my first term would be negative 2, because that would be my a sub 1 after I plugged 1 in for n. My a sub 2 would be after I plug in 2 for n, so this would be 2 minus 3, and that next number would then be negative 1. My a sub 3, or third term in this sequence, would be 3 minus 3, which is 0. Now, what's going to happen probably after the third term is that you'll see a pattern emerge from left to right, and then you can either assume the fourth by that pattern, or you can just plug in the fourth number in for n, so 4 minus 3 is 1. And so this, my friends, is our first ever sequence together. This is an ordered list of numbers starting with a sub 1 through a sub 4, because the instructions in this worksheet has told you to find the first 4 terms, and here they are. We can do the same now for problem number 2. And the level of work that you wish to show may be your own decision. I like to show just a little bit of work, at least that'll give me something to work off of if I make a silly mistake on a test. So I'll do a little bit in my head, because I'm going to plug 1 in for my a to give me my first term of my 4-term sequence. And I'm going to have 1 plus 2 times 1, so 1 plus 2. So the answer here is 3. That is the first term, and I put a comma there to separate that from the other 3 terms. My a sub 2, plugging 2 in for the n, so this would be 1 plus 4, and 1 plus 4 is 5. A sub 3, plugging my 3 in for n, so this is 1 plus 2 times 3, which is 6. Please make sure you use order of operations correctly and don't just go, if you have 1 plus 2 times 3, don't go 3 times 3. This would then make a 7, and then I can assume that the next number would be a 9. And to check, I would plug 4 in for n, and 1 plus 2 times 4, which is 8. 1 plus 8 is 9. So that's how I will do these 2 sequences. And we will note that these sequences have addition in them, and these are arithmetic sequences, and actually my video that comes after this will talk specifically about addition patterns. So let's look at this exponential pattern here. So I'm going to plug 1 in for my value of n. So this gives me 2 to the 1 minus 1, which is the same as 2 to the 0 power, and 2 to the 0, excuse me, I wrote that a little poorly there. So, and 2 to the 0 power is 1. So 1 is my first term in this 4-term sequence. I'm going to plug a 2 in here, and this is going to give me 2 to the 2 minus 1, and that's 2 to the first power, which is 2. And then a to the third power, so this is 2 to the 3 minus 1, so that's 2 to the fourth, which is 4. And then the next number is going to be 4 minus 1, so that would be 2 to the third power, which would be 8. So this gives me my 4 terms here of this exponential sequence here. Now we're looking at this partial quadratic sequence, which is going to be a little fun. I'm going to show a little bit more work here, because I'm going to plug in 1 for 1 squared, which is 1, plus 2 times 1, which is 2, so my first term is 3. I'm going to plug in my 2 here, so this gives me 2 squared, which is 4, and 2 times 2, which is 4, and so there's my answer is 8. Let's see, a cubed, plug in 3 there, and it gives me 9. And then 3 times 2, which is 6, so this gives me a total of 15. All right, so now you'll note that if you're trying to find a pattern over here, it's going to be rather difficult. But finding a pattern over here is actually pretty good, because if I look down this row, these are just a list of squared numbers like 16, 1, 4, 9, 16, because this is 1 squared, 2 squared, 3 squared, 4 squared. And then this would be 2, 4, 6, this would be 8, because this is 2 times 4. So my next number here is going to be 24. So there is my list of the first 4 terms in this sequence that we're drawing. We are going to look later on in this chapter at arithmetic and geometric, but we're not going to look at some of these more tricky patterns. This first section actually makes you work with them a little bit, but the formulas and most of the things we have to memorize are about arithmetic and geometric. So let's continue on to problem number 5 and 6. Alright, so problem number 5 here is another tricky pattern, and this might be one that's best with using fractions here. So my a sub 1 is really 1 plus 1 over 1. So 1 plus 1 over 1 is the same thing as 2. There's my first term. A sub 2 is going to be 2 plus 1 over 2, or 2.5. That's my second term. My third term is going to be 3 plus 1 over 3, so that's 3 1/3. And the next one, a sub 4, that's going to be 4 plus 1 over 4, and that's going to be 4 1/4. Alright, there's my first 4 terms of this arithmetic, or excuse me, not arithmetic, excuse me, this sequence that has a, oh boy, let me think, this is just straight up linear with, if I just had n or x, and this would be a inverse right here. So there. Took me a little bit of time to find that word. Alright, so now we're going to look at this is what happens when you go without a script. You're just kind of doing the problems and saying what's in your head. And boy, I try to get these done in one take, and sometimes they're good, sometimes make little vocal flubs like that. Of course, send me mail about that. Alright, so a sub 1. I'm going to plug 1 in for this, and then my negative 1 is going to get raised to the first power. So so we do order of operations. Negative 1 to the first power is negative 1 times 1 is negative 1. When I describe this in class, I call this an oscillating problem, because if you look at a number line and you imagine going from 0, like we're starting here at negative 1, and then if I go to my second term right here, my second term plugging in a 2 and negative 1 squared. Negative 1 squared is positive 1, and positive 1 times 2 is just 2. So you'll see that we kind of jumped to 2 right here. So we went from the negative 1 to the 2. And I call this oscillating is because I'm going to kind of oscillate from positive to negative and back again. As you see that I plug a 3 here, negative 1 to the third power. Negative 1 to the third power is negative 1, so this gives me an answer of negative 3. And so now I'm over here at negative 3. So I kind of showed this like a fly or a flea that's actually jumping longer and longer each time, like boing, boing, boing. And the next one's going to be all the way over here at 4, and the next one's going to be at negative 5. So every single jump gets bigger and bigger. So a sub 4 is going to be 4 times negative 1 to the 4th power. So there it is, positive 4. And it's positive 4 because negative 1 to the 4th power is 1. Actually, any negative 1 to any even power will be positive 1, and negative 1 to any odd power will be negative 1. Alright, so that's cool. So to finish up this video here, the last 2 problems are actually rather quick, because one of the coolest things about having the equation, and this is great when they give you the equation, is you can go immediately to any term you want to go to. And in this case, that a sub 12 is going to be the 12th term in this sequence. Like, we don't have to list 1 through 11 just to get to the 12th term. We're just going to plug the number in 12, and then 12 plus 1, which is 13. Multiply this together. A sub 12, or the 12th term in this sequence, is 156. Now here, if I just plug the 5, so a sub 5 is the same thing as 2 to the 5th power. That means that a sub 5, or the 5th term in this exponential sequence, is going to be 32. Starting off with 2 to the 1st power, 2 to the 2nd, 2 to the 3rd, 2 to the 4th, this would be 2 to the 5th. Now here we have, well, it isn't actually quadratic, because it's going to be linear once we actually plug in our number here, because if I plug in a 6, I really just have 6 plus 3, which is 9, and 6 plus 1, which is 7. So 9 times 7 right there is going to give me 63. So there's that. I mean, that's pretty much straightforward. And for our final problem here, we're going to have a little bit more tricky algebra here, but nothing too bad, because going to the 7th term of this, I'm going to have negative 2 raised to the 7 plus 1, which is 8, all over 7 plus 1, which also happens to be 8 in the denominator. So there's my 8. So negative 2 raised to the 8th power, and this is another warning that please, if you type this into the calculator, make sure you have parentheses around it, because you don't just want the 2 to be raised to the 8th power. You want the negative and the 2 to be raised to the 8th power, which gives you a positive 256. Like the negative problem up above, a negative raised to an even power will be positive. And then this simplifies since these are evenly divisible, and 8 is a factor of 256 32 times. So the 7th term in this this little oscillating pattern here would be a positive 32. Well, thank you for watching this video on Introduction to Sequences. My next video is going to be Introduction to Series, which will take equations like these and deal with adding them up. So thank you for watching.